Cool. We're about a minute early, but we'll go ahead and get started. So welcome everyone. This is our evading detection and beginner's guide to obfuscation webinar that we're doing on this fine Saturday morning. I got Coin here with me as well as Vinny Bot or Vincent. So what we're going to go over today are kind of the different goals of obfuscation. We'll get into it, but there's really two different goals. Then we'll do some AMSI and Defender overview, like how they work, as well as just kind of how AV and EDR in general work on detecting malicious code. We'll go over some of those various methods that they'll use. Everything from, or we'll cover a bunch of different things from, you know, string matching or byte hash mashing to like EDR hooking. Some of the more active and advanced stuff, we'll touch on the topic of how the detection works, but we're not gonna go through the evasion part of it today. There's just not enough time. When we originally pitched doing this webinar internally, Coin wanted to do it for an hour. I told him that wouldn't be enough, and so we made it to 2 hours, and we'll see if we get through all the material I have, because I really like talking about this. But then we'll go over some analyzing scripts and code, and I'll show you guys kind of the process I use for obfuscating. And then we'll go over some bypasses, time permitting, for once you have like your initial foothold or stager on the box so you don't have to deal with like the active evasion and doing all the obfuscation. So we are specifically focusing on .NET code obfuscation, so more specifically C# and PowerShell. There will be a fairly heavy emphasis on PowerShell. The heuristic detections by AMSI/Defender are a lot more robust for the most part for the PowerShell runtime than CLR. I used to talk more trash about the CLR detections until last night when I was working on, I don't know if you guys were in the general channel on our Discord, I was working on obfuscating a C# injector, code injector, because that was requested by a bunch of people that we go over obfuscating that, and the detections around XOR encoding and that kind of stuff in the CLR are actually pretty robust, or getting much more robust, so a lot better than I've seen. So I think they made some updates in the last month or two on their underlying detections. But all the principles we're going to talk about apply across all code languages. It doesn't matter if you're using C, C#, PowerShell, Python, like all the general concepts we're going to talk about apply equally. So I like to divide our obfuscation into two primary goals. One is to prevent reverse engineering, and the other is to evade detection by antivirus and like threat hunters if we have like active defense on the network. So preventing reverse engineering for what we do is often not necessarily the primary goal, because we don't necessarily care if our tools get, quote unquote, burned and people see what we're doing, because in a week or two engagement, the timeline for them to actually do like full reverse engineering and understand everything that's going on isn't long enough, and it's just that's not our primary goal, to like maintain the tools to make sure no one ever sees them and figures out like what information we stole and that kind of stuff. We will do some of it to like hide our C2 address or what comms channels we're using. Obviously using things like DNS over HTTP to like get past firewalls and that kind of stuff is an evasion technique. It's also kind of preventing some of our reverse engineering might help hide that that's what we're doing, or like what our internal pivot points are. Like, so we don't want like an agent that has like a list of all the other computers we've compromised like in memory or something like that. So we do pay attention to those, but preventing reverse engineering is not the primary goal for, in my opinion, for like a red team engagement in terms of obfuscation. So instead, what we really want to focus on is like our evasion of AV and EDR, and then threat hunters as well. I'm working on building a a new slide, and I might write a blog post about it. If you guys follow Spectre Ops, they have some they have a post up about what they call the funnel of fidelity on how response, like a SOC should go about responding, and how you start like all the way up at the collecting everything, getting down to like your instant response, where you only have like one or two events that you go do from like the thousands of things that you collected, or even tens of thousands of things that you collected. And that is essentially like Blue's kill chain. So we can actually use that funnel of fidelity to model how we want to start attacking and or doing our evasion. So there'll probably be a blog post coming out at some point in the next month or two about that kind of concept of abusing Blue's kill chain, whereas they often try to defeat our kill chain from the red side. We also will look at like identification of analysis techniques, like see if we're going through a sandbox, like for email servers, or depending on how they have their network set up or how the antivirus is set up, it might sandbox a new document or something temporarily, and then if nothing suspicious happens, it releases it from the sandbox. So we do that. But we can also change our indicators of compromise. That's the hardest thing to do, because it's more likely to result from building like a new implementation rather than through obfuscation. Although that line will get fuzzy sometimes as detections get better. Especially, I'll talk about it a little more, but math is really hard to obfuscate away. That's what Defender and a lot of the modern AVs are focusing in on now. Like your IC4 encryptions, or like your XOR encoding, that kind of stuff, because you have to do the math in certain orders and that kind of stuff. Like you can change up some of the orders or add in some obfuscation to the math a little bit, but the math ends up coming out the same and on the other side of it. So math gets really hard to obfuscate out. So but also other indicators are, using dynamic invoke instead of p invoke, that kind of thing. So the problem with obfuscation, though, for trying to break our signatures, especially if we're on a high security network with active hunters, is that it's the more complicated we make the obfuscation to try and defeat the AV, the more that immediately jumps out at a human. So like, just for an example, like sometimes unobfuscated code, if you can get away with it, can actually aid you in against hunters. We had last year, like a major hotel chain called us because apparently some of our code showed up on their network, and they were telling us that it actually took them a little longer to respond than they typically do, because the code wasn't obfuscated at all. So when they saw it, they just thought it was someone running like tests on the network or something like that, or like one of their red teams doing something, because they expected adversaries to obfuscate the code. But just kind of to emphasize that point, this is kind of like a heavily obfuscated Empire payload ran through invoke obfuscation without the base 64 encoding from the PowerShell script block log. And even without knowing what this is doing, just seeing this garbled mess across the board is kind of jumps out and says like, that's probably something suspicious going on, because normal code, if it's supposed to be on there, isn't going to look like that for the most part. Whereas if we go down to a complete unobfuscated code from a human standpoint, this doesn't immediately jump out as bad to us, because it just kind of looks like code, and we have to actually go read what that code says and figure out what it's doing before we know whether or not it's malicious. AV and EDR help us to accelerate that process, but just looking through logs, it doesn't jump out at us immediately. So I'll just pause for a second here. Does anyone have any questions yet? I'll talk forever without taking questions if I don't make myself ask.
How about before you continue, can you just promote Vince and me real quick, so we have organizers?
Yeah, I will do that, and I will put the slides into presentation mode. 1 second. So let me promote.
I mean, you're jumping in and out of slides a bunch when you do your demos, so.
Yeah, for now I can. guess. Sorry about this, guys. Just making sure that they can help everyone in the webinar.
There we go. Perfect.
Cool. Stalin, it did start, so you should be able to do that. Oh, that's not helpful. Crap. When I'm going into presentation mode is putting it my other screen. It is not liking me go into presentation mode, so I will just zoom in some. Is that better? Yes, the slides will be available. So
Normally when you go in presentation mode at the bottom, you can say switch screen, if that helps.
that's what I thought, but
Yeah.
it's not.
Let you select the monitor. That's what someone just said.
Yeah, it's not letting me though.
This is why I think moving to Zoom instead of GoToWebinar might be a good choice.
Why is it not letting me select my monitor? That's really stupid. Well, I can do this for now. Hold on. Let's see, view in the menu bar. And I see switch windows. Where's my... This is why I don't do things in public like this. View doesn't have a monitor. Okay, we're just gonna do the presentation views.
So you just put in presentation mode real quick and you should be able to do it from there.
I'm clicked on view and it doesn't have me the...
Go to bottom. Go to the bottom right and just go to presentation mode. As we do this all in public.
I know I am in presentation mode. It's just going to my other, it's going to my other monitor. That's what I'm saying. So we can just do this. Okay, now you guys should be able to see it in presentation mode. Is that better?
Yeah, that works.
Okay, cool.
I don't know why it wasn't working the other way, but cyber.
Sorry about that, guys. Okay. Okay, so we kind of have two different methods of detection. They're not really different methods, but two different categories of. We have our static detections, which are like scanning our code when either on disk or when it's loaded in memory, which is what AMSI does. And that's comparing, that's not looking at the behavior of the code, it's just looking at how that code is structured. So the simplest method of detection is hashing the file. So you just take a straight SHA-256 or MD5 hash and compare it to known bad hashes. That's not super effective because it you change literally anything in your code and it'll break the hash. So adding like an extra period somewhere, adding depending on the compiler, like a new line somewhere. Even changing compilers can cause your hash to, like the compiler version going from like a 4 to a 3.9 or something like that can change your hash depending on the compiler. So hashes are very, very fragile. So more often what you see is string matching. It's also known as, it's really better referred to as byte matching because we're not necessarily matching strings in the sense of strings like in our code. We're matching a series of bytes, byte patterns together to identify things that we know within code that would look bad. This is particularly easy in .NET because you're not going to full machine code. You're going to Microsoft intermediary language, which is kind of allows us, that's what allows for the portability of .NET code for you to switch, is because you're not actually compiling down to machine code until you run it, which is then just in time compiled down to machine code. That's why like IL-SPY and all those things can like really effectively decompile .NET .NET stuff. And then we have hash scanning, which is like a combination of the two. It's taking byte matching and instead of trying to match the pattern of bytes specifically, it's taking chunks of bytes and hashing them and then comparing the hashes for known bad. It's a little faster than just doing like straight byte matching, so you'll see that. Then we also have like what I like to call heuristics type detection, even within that static method, because you can look at the file structure. That's how you can detect like packed EXEs. If you want to go do some research on it, there's like a whole bunch of different indicators that you can use just based on the actual like header structure and the code structure, or not the code structure, the byte structure in EXEs without being able to decompile them specifically and see what's going on. There's like a whole bunch of indicators, and people publish like thesis on like the math behind like analyzing like the file structure. You can also look at logic flows when you're using things like scripts or .NET code. You can compile out or pull out like the abstract syntax trees or control flow graphs, which show like the order that things are occurring in. That's pretty effective because now you're no longer tied to necessarily specific implementations of like method names or that kind of stuff, but you can actually look at the flow um, of the code and match it to the like hierarchy within the code. That's kind of a more advanced thing. For AVs, I don't know how many of them are doing like a full logic flow analysis, just because it can take a while and it gets complicated. But it is possible. There's again a bunch of research papers out there. What you see most often is like rule-based detections, which I like to refer to as context based detections. That's when you start combining things, like if we see RC4 encoding with a download command, that's bad. But if you see just RC4 encoding or just a download command, either of those on their own are okay. And then what gets taking that a step further, Defender and others, we don't have the source code, but most likely are using some kind of aggregate risk, or well, we know they're using aggregate risk. They're probably using some kind of vector mapping within like their machine learning kind of stuff to create risk vectors, so it's not tied to any specific rule detection or whatever. But as you get more risky, simpler things become more likely to trigger, and specific things will elevate, and it gets really, really deep into the math if you've learned about machine learning and know about like vector math and that kind of stuff. It would be interesting if someone wanted to do like a thesis or whatever from an offensive side. As more of these things are using machine learning, it should theoretically become possible to use adversarial AI techniques in your code to start preventing detection, so that it just doesn't know how to classify your code. But AMSI and Defender use a very like robust aggregate risk assessment. We're not going to go too deep into that, just because it's describing the inner workings of AMSI is like a whole like 30-40 minute slide deck that I have, and I don't think we want to do that right now. So dynamic detection is all of our behavioral detection, like sandboxing it, looking for a Microsoft Word document trying to call out to the internet, or talk to LSASS or something sketchy like that. We can use system logs and events. That's for Windows. That's most often event tracing for Windows. ETW is a really effective means of doing .NET detection. That's what a lot of the advanced EDR stuff is using now. Although a lot of them have the capability, they're not necessarily always configured to use it. We had like a prior student tell us that they were going against like CrowdStrike, and they didn't have it configured properly, so PowerShell and stuff was working for them, and it showed up in the CrowdStrike logs because they were using ETW even after they used an AMSI bypass, but none of the ETW detections were configured properly. And then you also have API hooking, which that starts getting really down into the like computer science, memory management stuff. That's where dynamic invoke that Rasta Mouse and then published last year come into play to like skip around like your translation tables for API calls and that kind of stuff to avoid them. So we'll do just a quick overview of AMSI for anyone that doesn't really know how it works. I'll take another pause for questions right now.
Yeah, how about I'll read a couple off for you to make it a little easier.
Okay.
So, let's see, Joe asked, realistically, how much of developer C programming, Guru, PowerShell, Ninja stuff do you have to be effective at to bypass most endpoints?
So to do it by hand, especially nowadays where it's getting better, is getting fairly time consuming. I like to do some initial obfuscation by hand and then use like the published tools like invoke obfuscation or confuser ex for C#. And when you kind of combine those, once you have a good understanding of the stuff that's being searched for, it's not super hard, but it does start getting out there. Someone asked, will we ever run out of ways to obfuscate? Yes and no. As they get better at the AST identification, so the abstract syntax tree identification, and like I said, there's certain things that become really hard to obfuscate, like math. Like if you want to use RC4 encryption, it becomes really hard. Now, using built-in libraries often helps avoid that, rather than rolling like a custom RC4 encryption in PowerShell or whatever. It does. Those do help obfuscate, since most code nowadays does use some form of encryption for like your connections and that kind of stuff. But the math, where you're doing math, is where it gets really hard to obfuscate.
I know you have some good resources. Yeah. Somebody was asking for resources. I know that you have a couple of things that you typically recommend. Do you happen to have those on hand?
Like for like doing my analysis, or what kind of resources?
The obfuscation stuff.
Oh, of invoke and confuser and stuff. Yeah, I'll send out. I will like put together like a GitHub page or something and post it and then share it on the Discord. That's probably the easiest way to share those. Yeah. So okay, so we'll go ahead and move on now to the next section. Okay, so AMSI is the Windows Anti-Malware Scan Interface. I'll let you guys read this real quick. This is just the straight Microsoft definition. Has a bunch of buzzwords in there about enhanced malware protections and that kind of stuff. But what does that, like realistically mean? Is that when we're talking about scripting languages, so specifically VBA, it actually has detections now for JavaScript, PowerShell, that kind of stuff. It's evaluating the commands at runtime, which means like if we're doing XOR encoding for strings that we then want to use like invoke expression or invoke command, the XOR encoding has to be undone because the just-in-time compiler has to be able to interpret the command. And that's where they're analyzing it, is that is right as it goes into the prior to the just-in-time compiler, which makes a lot of the traditional obfuscation for scripting languages not nearly as effective. But there's still ways around it. As of .NET 4.8, AMSI is now integrated into CLR, which is the common language runtime, which that's what C#, that's what everything runs on top of. Like PowerShell actually ends up going through the CLR at some point. Even the dynamic, was it DLR? Yeah, the dynamic language runtime stuff for like Silent Trinity. It's all like hosted on top of the CLR. So like it interacts with the CLR in various ways, but CLR is like the just-in-time compiler for all of our .NET languages. And so the other part about AMSI is that AMSI is technically, you'll see it used interchanged, but it's technically only an interface for antivirus. So it's not actually doing the detections itself for the most part. It's passing it over to Defender or to, you know, CrowdStrike or whoever's using it, or McAfee, because they finally came into the 20th century with their AV last year and finally started using AMSI. Actually, might have been the year before, but they were way behind the curve. So it's just kind of the data flow works for AMSI. You can see like PowerShell, VB script, other applications. We'll go through like the Win32 API layer, then it goes down to the COM API layer where the anti-malware interface is and the scan function is. That's where, if you've seen like the memory patching stuff, that's kind of where that's going on down there. And then we get to the AV provider layer, which sends that across RPC to your antivirus engine, which in Defender is the MSMP engineering or engine, yeah, the Microsoft malware protection engine. So an interesting note about the CLR hooks. So this is specifically for .NET Core because .NET Framework is not open source. As of November, they are supposed to be going forward as one thing, and everything's supposed to be relatively open source. But having talked to some developers and stuff, the general consensus is that like the whole open source part of it all being like one consolidated thing is really that .NET Core is just going to be running on top of .NET Framework as like an interface on Windows, and that the .NET Framework stuff's going to stay in. I think that's largely because it's just too hard to pull out the .NET Framework completely at this point. But I've been told by some developers and people a lot smarter on the inner workings of .NET that it's not going to be like a truly like one-to-one thing still. But so for the CLR core, there's only one hook for AMSI in the whole thing, and that is when you load it from memory. If you are loading from disk, it does not call AMSI. It expects there's different instrumentation that Defender is expected to use. But as what's interesting about that is that instrumentation is assumed for Defender. We don't know what instrumentation is available for other AVs that they are relying on AMSI. So that's just an interesting note that, you know, other EDRs and AVs, that they're not properly configured for on-disk stuff, that they might be missing out if they're only relying on AMSI for .NET because they aren't getting called from the disk load. So we'll go over some. This is just to point out, like I mentioned that like we have to unravel obfuscation so that the compiler can understand it in PowerShell and our other scripting languages. But it's interesting. But the key part of that is that the compiler has to be able to understand it. So PowerShell, this base64 encoded string, when you decode it, becomes write host test. And that's what the engine looks at. If you go look at the PowerShell logs, you'll see that it unwinds that and can tell that that's what it says write host test. But if you do like concatenation and break up, you know, test into TE plus ST, because the compiler can interpret that, it doesn't unravel that concatenation stays in place. And this is what allows a lot of our obfuscation to still work, is the fact that it's not combining everything into like a human readable form or to like the most simple version of the code. It's just unraveling it to a compiler interpretation. So that's why a lot of our obfuscation can still stay in place. So now we're going to go over some obfuscating static signature stuff. That's the bulk of the slides, of the Death by PowerPoint slides. We'll start getting to do some like demo stuff at this point. Are there any questions that I missed?
There's a couple in the channel. Vince, can you post the Discord link again? I think some people were asking for that. Thanks. Let's see. I'm scrolling back up. Are there any EDR AV solutions that have a good reason at this point to not hook into AMSI?
No, they all hook into AMSI at this point. I will say, so in my opinion, Defender actually has the best detection engine for .NET code. If you can obfuscate past the Defender engine and not get detected, there's like a 95% chance that you'll get past like any other AV EDR in terms of your static detections. Now, you could still get caught by like the ETW event tracing, by API hooking and that kind of stuff for EDRs and some of the more advanced AVs, if you're on like a enterprise network or whatever. But Defender's like just static detection engine is, in my opinion, one of the best ones out there. So we actually use it for the most part for obfuscating our code. We just test against Defender and assume that that part of the obfuscation is good enough when we go into, regardless of which AV engine we're going against.
Somebody asked the question if there's any tools we need to follow along for the webinar. Not at the moment.
Not at the moment. I saw someone say like, do they all hook or they should hook? I'm not aware of any major AV EDR product out there nowadays that doesn't hook into AMSI. I'm sure some of the smaller ones might not, but like CrowdStrike and Cylance and all those all hook into AMSI. Cool.
There's a couple people typing. There might be a question coming up before we move on. A lot of good links, definitely.
Yeah, so if a question comes up, just let me know. Okay, so for obfuscating our static signatures, what can we do? We can modify our hash, we can modify the byte strings, and then we can modify the structure of our code, which includes doing different implementations. Like I said, they're getting really good at detecting math. So the C# example I have to show you guys when we get there, I actually had to go do XOR in the XOR bitwise operation. I had to build a function that did it by hand, using like bit shifts instead of using the XOR bitwise operator, because it was impossible for me to obfuscate it out. So that's like certain ways for us to modify the structure of our code. Another way that the thing you can do is use reflection to break up your code into different domains and or like DLLs, so that when it's scanning your initial code, that's not loaded up, and you can leave that encrypted, because you don't have to decompile it yet, so that your script block or your exe is scanned with just that. And then once you are running, you would decompile it and launch another context, which that section would be scanned, but you're now preventing them from being scanned together and breaking up that context detection. So as I said, modifying the hash, we can change literally anything. There's basically no AVs out there that are relying on just hashes nowadays, but it's still a best practice to just go ahead and use like random capitalization and PowerShell and all that kind of stuff, which is just a note here. PowerShell ignores capitalization, and this is throughout, like PowerShell, like it ignores capitalization and commandlets. It ignores them when you use calls to like not all of them. So like the core ones, like MS Core Lib and stuff. But if you're using like the direct assembly call, quite a few of them will allow you to use like randomized capitalization in them. Some of them don't, but a lot of them do. But like I said, AMSI ignores it. It's not gonna full AMSI, but changing our hash is a best practice. C# is a much more rigorously typed and enforced coding language, so we don't have the same flexibility, but we can change like the capitalization scheme of like variable names or class names and that kind of stuff to modify things and change our hashes a little bit. So modifying byte strings is kind of where we make our hay. there are a lot of options available. We can change variable names. We can use concatenation, variable insertion, potentially the order of execution, depending on what we're doing. A lot of launchers and stuff like that do things in a set order because that's the logical order from a human standpoint, but they're not actually required to be done in that order from a coding or like machine standpoint, so we can mix that up. For C#, we can potentially change the variable type depending on what it is. So like using like a list versus an array, like sometimes we can use those interchangeably, or even use like a dictionary in places depending on the coding language. So there's different options there. So variable insertion is PowerShell recognizes the $sign and lets us insert variables, and we can break them up and then put them together. And so part of what allows us to get away with a lot of this in PowerShell specifically is that once a script block is compiled, it actually has a flag in it that's set to like has been logged, and so it actually keeps the IL that was compiled attached to that script log or script block, and AMSI is only called during the compilation step. So when you're rerunning that code piece again, as long as the intermediary language is still attached to that script block, you can skip the AMSI check. And so like that's why once we get the word that would flag or whatever in there into like memory and it's been executed by PowerShell once, it doesn't trigger it a second time. And that the has logged is for script block logging. There's a has compiled flag attached to your script block log that once it's compiled, it doesn't check that code anymore. Variable insertion is supported in C# as well as of C#6. And we're gonna go after I get through these. There's about 3 more slides. I'm gonna go show you guys how this looks on the compilers. I have like ILSpy set up for this. So if you use like a compiler, decompiler like ILSpy to examine your file, for some reason like ILSpy, like the intermediate, I've looked across a couple of them. They all treat like the variable insertion as a concatenation once it's compiled. Which is odd because when we get to, can't remember if it was format, I think it's format string. We'll get to it in a second. So we can also use format string for PowerShell to get things through. It looks like this. I'll demonstrate it. Yeah, so format string is also the same thing, which is kind of concatenation, but when you use ILSpy to decompile it, it actually shows up as that variable insertion in the code. I don't know how much it matters for detection methods. I just find it kind of interesting that of how the compiler code is getting treated. Okay, so let's go look at these things. So
before you do that example real quick, Hubble, there's a pretty good question here that if you just have a second.
Yep.
Do you think on the long run, AMSI uniformization on the scan interface is a good thing?
The AMSI, I'm sorry, say that. Where was the question?
It was from Archie.
Yeah.
I can pin it for you if that makes it easier.
Yeah.
It's not letting me pin it. Great. Come on. Oh, there you
go. The sun's right in my eyes on my secondary screen. AMSI uniformization of this. Yeah, I do think that in the long run it's probably a good thing, because it standardizes how AV will look, and it just allows everyone to, first of all, it's good for the industry. It makes it easier for people to get access to that kind of thing, so that like new AV systems and stuff can interface with it. And it's just providing introspection to the code. It's not doing the actual detection, so all the detection methods and stuff are still proprietary across. So it's not like everyone's forced to use the same detection methods. It's just allowing them access to a lower level inspection in the compilers and that kind of stuff. Oh, someone just mentioned threat check. We'll actually talk about that in a second because that's what I use for for C# stuff as well. So we'll go look at this real quick. So everyone can see my VM right now, right? That's what I'm showing.
Yep, I can see it.
Yeah, cool. So I just have for C#, I just have those three things. So the first one is using variable insertion. When we decompile it, it does show the string, and then it gets converted to like this concatenation. And if we go look at concatenation, real quick.
Does it let you make the text any larger, Hubble?
Oh, yeah. It's not wanting to let me.
Does Control plus work?
No, I tried that already.
All right, well, this is what we get for doing it live.
Why does it not have a? Nope. It had never even occurred to me to try. Yeah, I apologize, guys. So I can do this though. I can show you what the decompiled code looks like in Discord, if that helps. So, but the main thing that from the decompiler standpoint is that concatenation and variable insertion look identical, whereas when we go look at, we'll make this large again. When we go look at that format string, it comes out as a different variable insertion that looks like this. So I have checked though, even though the decompiler looks identical between concatenation and insertion, you do end up with a different code hash. So it is not treated as identical by the compiler. It just, when you decompile it, the code structure looks identical. So you do end up with a different hash, and so, but if they're doing code structure analysis, then your code looks identical. So just some things to keep in mind. And then we can go to PowerShell just to demo it real quick. So for all of this, I recommend having a known trigger that you use to test against. I've just always used the word AMSI context because I know it'll trigger it. So, except my AV is off. So one of the best updates that Microsoft has done recently is made it so we can manage the real-time. Oh, it says real-time protection is on. My VM might be broken. Okay, there we go. So I use the string AMSI context. Oh, thanks. And it produces a detection. So like I said before, we can do var1 equals, this is why I should have had it on a notepad that I copy over, which I do have for other things. I just didn't do it for this part. So we do AMSI.
It's only something you teach in the class.
I know. Do as I say, not as I do.
You're supposed to never type things. You're supposed to put everything in a notepad and just copy and paste it, which is what we teach everybody, and then he still does this. Yeah, you can zoom in on that one. That one should work.
Oh, yeah. Why is my string insertion not working?
Magic.
Oh, because I need to do it on the back end. That's right. I forgot. Never mind. Ignore me. That's what I get for doing it live. Is that zoomed in enough for you guys? So Itachi, there's actually PS AMSI can help do that, and I believe AMSI trigger can also do that. I don't think does threat check support using PowerShell scripts, or is that only for C# or for like your .NET, like your binaries and stuff?
Yeah, I don't think it does.
Yeah, so now there we go. Now that I rode the struggle bus, so now we have var2 and AMSI context is still going to flag it if we try to do it directly. So there's that part of it. So moving on. Now we will talk about some syntax tree stuff. And where is my manager? So abstract syntax trees, we're just going to talk about real briefly because they get fairly complex. And I
Show
had
your
like
Discord channel, by the way.
oh,
Sorry.
whoops, my bad. Wrong window open. There we go.
There you go.
Because they get really complicated. I was trying to set up a demo to show like there's some, I can show it still. There are like some GUIs out there for like PowerShell and stuff where you can give it a script and it'll show you all of the syntax trees you have, and you can walk through them to see how things are looking. But syntax trees are like I said, they can use it to break up code into chunks and look for those bad chunks, because at some point you have to have those trees, often not, even if you move the code up a little bit, because they're all linked to each other for the code flow. But this is a very deep rabbit hole to go down to start understanding them. But how it works from like a very top level is like you have your script block AST for PowerShell, which is like the entire script block that you're running. Then you have your name block, which is basically the same thing, but you can actually, I haven't figured out exactly the definition because, like I said, this is kind of opaque when you go look at the documentation and stuff of what constitutes a like name block AST, because sometimes you'll see like a second name block in your code randomly. Often those are tied to like what appears to be just that, what they call like their deep inspection. So every function, like if you have a script block that has like 3 functions in it, you'd have this primary script block and name block, and then each function would also have a script block and name block AST associated with them. Then your function definitions come down, and then you start getting down to your breakup, like what's calling your pipelines, what's actually running your host or your command, and then you get all the way down to like your string and variable literals that are the smallest part that you can break it down into. When we do like a more advanced seminar, we'll go deeper into like the abstract syntax tree theory and that kind of stuff, but it's something to just be aware of because it is a way to look at your code. And just here's another example of how it gets broken down. And as you can see, like this is just one simple command, and it breaks down into like 20 pieces. They're very, very complex. But changing your abstract syntax tree can help you obfuscate your code. So you can do that by setting like global variables and stuff like that can help break it up, because then they're not being defined as part of your command, so they're defined elsewhere, which changes your abstract syntax tree and those kinds of things. So like just to give you an example, and actually I don't have it installed on my VM, but Visual Studio actually does have a available like AST analyzer, like for a GUI interface that you can go look at them. I just don't have it installed on this. So where is, yeah. Why does the toolbar search suck? Okay. And I've already installed it because that required being connected to the internet. And we don't want to connect to the internet because Microsoft pushed an update last night that broke my examples. So that was fun. Yeah, we've had Microsoft seems to like target our webinars. They broke AMSI one time for the first time we were teaching at DEF CON so that none of our instruction material worked. And then what else have they done? They updated the detection method the day before our webinar, and one of their guys was showing up to the webinar. And then, but we still managed to get through that one. He was impressed, but they seem to like timing their stuff with our webinars. Although they are constantly pushing updates, like they push updates pretty much every day. It's pretty impressive what they've gotten to with AMSI. That is not what I wanted to do. So here we go. And I don't think I can zoom in on this one either. No, I can't. So this is it's called show PST.
You gotta switch screens, by the way.
Oh, dang it. Sorry guys, I forgot that
I'm here just to remind you.
Different screens. Yeah. So this just has like the breakdown of all our PSTs. It's called or ASTs, sorry. Like I said, it's called show AST. You can find it on GitHub. And so like it shows like an if statement, and you can click it and it highlights what this AST is composed of in your code. And you can actually, it's hard to update it in here, but it will actually let you modify your code in here and then refresh it to show the changes in your ASTs. So as you can see, it just like this is like an assignment block. We're setting this FF6, and then it walks through the there's our variable that we're defining, and then it can show you all the expressions that are being executed within our definition, since we have like a bunch of concatenation and stuff in a line. Each of those concatenations composes of a like binary expression AST that goes down to our string constants and that are added together. And so there's that. Is there any questions, Anthony, so far?
There was a couple. Let me see. There were some much earlier. Min, was there any that you were tracking? I think you answered all the ones. Unless somebody has one that they're typing up right now.
Okay.
I think we're all caught up on most of the stuff.
So someone asked about using like signed DLLs and stuff like that. So that's where like the ETW event tracing and the like sorry, I'm totally blanking. Like the when API table translation tables and stuff down to the kernel level all come into play, because you can analyze those and look for suspicious sets of those calls. So like if you're on a network that you don't expect to see code being compiled regularly, seeing a just-in-time compile event from ETW with like the MS build or something like that is a big flag. You can see those in ETW. The just-in-time compiler gets called all the time from MS build. Like if you go pull like ETW logs, and I'll show you guys how you can set that up. it like calling like MS build produces like hundreds of events in ETW. So like you can look for that kind of stuff. You could look for, if you are doing like code compilation, you look for like a just-in-time compiled with suspicious API calls, because like the interop calls are also shown through ETW, and as well as you can do API hooking and that kind of stuff. So we'll just go through like I'll show you like some of the examples I had of the code. Specifically, we'll look at the C# example, because I know when I asked earlier this week for what people wanted to see, they're asking about a C# injector, like for injecting shellcode. So this is code I pulled from Kevin's on our Discord's Bad Rats GitHub or GitLab project. That's like a C2 framework that he's built. So this is what it looks like. Oh, this is the obfuscated one. So this is what it looks like by default. We can walk through it just real quick. It has like a main section that has an embedded key, and then a base 64 encoded, an XOR encoded shellcode that is then called to our XOR encryptor here. And then we have like all of our memory flags that are required for it. And so it's fairly straightforward, like in terms of the, well, it's lots of low-level memory stuff, but it's in terms of like the number of things we're actually doing, it's not super complex. But if we build the project, let me make sure that I have detection on. So if we build the project, we build the project, and if we go to try and run it with Defender on, we will get yelled at, and it'll detect it as bad. What's interesting, so something I've noticed, just as a note when you're testing, is that if Defender blocks it through AMSI, like in the CLR, and you're trying to like reflectively load or things like that, it doesn't necessarily tell you it was because of antivirus. It'll often just say that it failed to load. So if you are having issues with getting something to work on like a box you're testing, make sure like you have AV off and that that's not the immediate issue, because Defender will sometimes block really random stuff. They actually, like I said, they push updates all the time. So you'll occasionally see where they push updates that are like really restrictive and start blocking tons and tons of things, and then a few days or a week later they'll roll that back because it was overly restrictive and causing issues for customers. So sometimes things that shouldn't be like triggering like bad behavior or malicious behavior end up triggering it for like a few days if you like had been to update your code. So if you're just doing any C# development and not getting something to load initially, like that's always the first thing I check. So now if we, some people were talking about, using a threat check. So I'll just show that real quick. Oh, go, stop giving me, there we go. The Discord notifications from you guys' messages were blocking my virus or my ability to manage this. So yeah, also when you're doing your code development, make sure cloud delivered and automatic sample submission are off and you're not connected to the internet. You don't want to burn all the code that you just started working on. So now we will recompile this. And so if you haven't used threat check before, it is a very useful tool, but it's also sometimes it has its limitations, because I'll show you specifically with this. And I am showing my VM right now, right? Since I forgot last time.
Yep.
Okay, cool. Then do threat check. And grab this. Okay, so what threat check does is break all of your code into like a bunch of different pieces, split your binary up into a bunch of different pieces to look for where the detections are occurring. And so this is, so we get this check, and sometimes it's hard for us to get to know what this is talking about. Having done this, having obfuscated this code a bunch, I can tell you that what this is flagging on right now is our XOR code right here. So we know that it's flagging on that, but so how do we? And so let me take a step back. I know that because I spent like 2 days working on this a bunch, so I know where it's looking at. If we don't know what's going on, because that's not necessarily the most informative piece of code looking at this, how do we go about breaking this up? So the way I like to start things is removing like all of the known or all the things that are likely to be triggering. So I would remove like the string, like the key string, the shellcode strings, and all that stuff to start with our check and see if that changes anything. So like we can go ahead and remove this out and just to show it, and then rebuild our project. Oh well, except we gotta. I forgot about that part. This is a lot easier, or that method's a lot easier in in PowerShell because it'll let you get away with not defining things. It just throws an error that it doesn't like it. So just change this to something that works. So we'll change this to encoding.get.utf. So we can rebuild the solution, and now we can run threat check. And so like this code won't run right now because that's bad. And interestingly enough, our shellcode remove does fix that. So now we have some options that we could start looking at. Is there a better way to encode our shellcode, or are there other things we can do? I actually didn't expect that to work, so that was a little surprising. Because our other option is, so like I said, I know math in general is what a lot of these detections are built around. So another thing I would go check when starting out would be where our XOR encoding is happening. So we'll take this out, and then we're just not going to XOR encode it. We're just going to convert our base 64 string like this. Rebuild our solution, and then look at it again. And again, we had no threat found. So now we have a couple of different options to start looking at, like how we go about obfuscating this. I have a fully obfuscated version here that I can show you guys. So like I started off by, it didn't really matter where we had our key and shellcode in here, and it being near this file location for the process we were starting was triggering things. So I moved it down here, which got rid of our initial trigger with the code. I then started doing like my, this is where I actually re-implemented the XOR encoding by hand instead of using the bitwise operator, which is the up caret. but let's see if it didn't break on me. But I'll show you something that's kind of interesting about this that goes along with the like changing our code structure and that context matching type stuff. So like if we go and run threat checker or threat check against this, it's going to pass right now. Oh, that is not what I wanted. I wanted this. So it has no threat found, but I was testing some other implementations and have this, oh, let me zoom in because you guys can't read that. I have these 3 lines of code here that are actually doing absolutely nothing because it was a different implementation I was testing for the obfuscation. But if I remove them and compile the code, it'll actually trigger our detection again. So if we rebuild this and go through and do it, we now have threats, even though that code was totally unrelated to anything. It literally does nothing. It just defines 3 variables that aren't used anywhere else in the code. It's enough to change that risk level assessment by Defender to be under to not be malicious, because there's actually so AMSI/Defender actually has a numerical value that it adds up, and if it's over a certain value, then it's considered malicious. If it's under a certain value, then it's not considered malicious. I would love to be able to get access to like how it's actually doing that math for that number, because I've yet to be able to get a return of the exact value that Defender is evaluating our code at. But when I asked a Microsoft developer about it, he kind of just laughed at me and said, I don't think you'll ever get access to that. So
Jake, we got a couple of questions. If you just got
yeah.
a second, if you want to take a quick break. Looks like a couple people are asking, what's the difference between threat check and defender check, and why do you prefer threat check? I don't know if you happen to use both.
Yeah, I've used both. I don't have a real reason to use one over the other. I'm a fan of Rasta Mouse, so I use a lot of his stuff, but yeah, but I don't think so. Exploit code. I don't think AMSI is actually doing any detection, so I'm not sure like what the AMSI engine in Rasta Mouse is doing versus the Defender engine, because AMSI is just the interface that sends it back.
Rust Mouse is a wizard. That's valid. Let's see. I think somebody was asking, how do you go from the bytes directly into the function? I know that was something that might have looked like a little bit of black magic.
Oh, the XOR. Yep. Oh, like I said, that was because that's just because I spent 3 days obfuscating this code and playing with it to get a bunch of options to show you guys. So I ended up figuring out that that code correlated to that Z-wrapper, method name is how I know. Like the black magic part is just a whole bunch of trial and error.
So maybe somebody can come up with a really cool way to do that. Much easier.
Yeah, because there's actually like Rostamaus has a obfuscation walkthrough for like a very quick obfuscation walkthrough for some Covenant stuff, and he kind of does the same thing where he's like, well, this clearly tells us it's here. And I'm like, without having looked at the code, like played with it a bunch, I was like, how do you possibly know that? And it's just you end up working with your code and figuring out what things correlate to.
I think we got time for one more before we keep moving on. It's like somebody was asking, this is all great, but once you fire it off into the internet, is that completely different?
So that's where, and we're not going to get to too much of it today. I have some in the notes. If you guys would prefer, we can skip to some of the bypass discussion stuff, or I could I have some stuff about like detecting sandboxes and like AV processes to like for doing like evasion type stuff. If you'd rather talk about that first, but the short of it is you really want to limit your obfuscation, or not, you don't want to. It's obfuscation is a pain and significantly bloats your code and is introducing like larger assemblies to that you're loading and that kind of stuff. So a lot of times we try to obfuscate the initial payload that then disables all of the monitoring tools it has. So we'll unhook ETW, we'll unhook AMSI and all those things, and then the subsequent loading that we're doing of tasks or additional payloads and that kind of stuff, we don't have to worry about the obfuscation because we've blinded the AV and EDR to what we're doing. Probably, Matt. You probably can map the bad bytes. I have not used dnlib too much, exploit coder. It's something I want to go look at. We still we are still probably doing 80% of our stuff in PowerShell because we work primarily with medium-sized businesses that aren't, like a Fortune 500 company and stuff that have the super robust EDR implementations and SOCs and all that kind of stuff. And we think that those size businesses get a lot more value out of us coming in and emulating the like APTs and stuff that are likely going to that they're going to encounter from like ransomware and that kind of stuff, because Ryuk and all those different and different payloads and stuff for the ransomware still heavily use PowerShell. I think last year set records for the amount of PowerShell seen in breaches, as well as I think CrowdStrike's numbers they put out was something like 80 to 90% of breaches involve PowerShell in some shape or form during the breach. So we still focus largely on we're still primarily using PowerShell for our engagements with those smaller customers, because it's much easier it's something they can do about, like, we can come in and totally smash their networks because they don't have the personnel and the high profile SOCs and that kind of stuff, but we'd like to get them against to the 80% threat that they can do something about versus the super high level APTs.
That brings up a good point, Jake.
So I don't use DNO. I have not used dnlib a ton.
Yeah, especially like the big thing that we focus on is threat emulation. So whatever we can tie back to like what APTs are doing or other threats are doing, the better for us, because it gives justification of what we're doing. Like, we don't want to roll in, like Jake said, and drop a bunch of 0 days, because that's not going to teach anybody anything.
Yeah, and so even if they do have a SOC, I still have lots of success using PowerShell. It's been a while since I went against somewhere with a SOC, but PowerShell is still so heavily used by admins, and admins do sketchy things all the time to make their scripts work. They find scripts on GitHub or through Discord from other sysadmins that someone wrote as a homebrew thing, and then they just kind of validate it and send it through. And so, like, I've been places where the PowerShell scripts the admins were using were producing so many alerts in the SOC that basically PowerShell was just ignored because they're like, oh, it's our sysadmins. Yeah, so we still see lots of success with PowerShell.
My favorite is when they disable command prompt and then you still have PowerShell access.
Oh yeah, that's also a fairly common one I've seen. Just another tidbit, since we diverged a little bit. If you're the other thing that you like that I have seen more than once in admin scripts is as a red person is go and dump the the PowerShell logs and go find the admins that have embedded passwords into their scripts to authenticate across the network. I've seen that more than once where we just dumped the PowerShell logs after getting on a computer and had admin credentials.
So I think going through the sandbox stuff and then maybe hitting over the AMSI bypass stuff with if we have enough time would be good.
Okay, yep, that's what
So.
I'm gonna do now. Okay. Oh, and I didn't go over my PowerShell obfuscation stuff, but it's a similar process. If we have time or someone really, or people really want me to go back, I can show the Empire obfuscation stuff I did. The C# one was just a little more interesting to me because this was the first C# obfuscation stuff I've done that was actually pretty challenging to get it through with everything in place. Usually like seatbelt and Rubius and all those things, you go in and change the namespace definition to just something random, and it'll get through Defender fine. So this was actually like one of the first C# obfuscations that were like that was a decent challenge to get it working. So now that we are doing or looking more at our dynamic obfuscation or evasion, what can we do about it? So we can identify known bad, which means like we can do like sandbox detection. We can look for known hunter or antivirus processes. The known hunter thing is a more of a carryover from what I was doing red team stuff for the Air Force, like when we were doing exercises and stuff where there were like active hunters that were like trying to go in and find you actively on the box at the same time that you were on there. Like a lot of times we would look for their processes for the tools we knew they were using, like Procmon and that kind of stuff. And if we saw it running, we would just like go to a different box instead of trying to play there where we knew they were looking. We can go to we could change how we are executing. So like we can inject in a different way, which is why there's a number of different code injection capabilities out there through shellcode or like Donut and those kinds of things. We can use a different download method. There's GitHub pages that are completely dedicated to download cradles because that's changing how we're downloading. So if they're looking for us to use a web client, web client.download, but we use like a MAPI object and go through Outlook to download it, then they're not necessarily watching that process. And then we can circumvent known choke points. So like EDR hooking for pinvoke is because there's a translation table, and if you're using pinvoke, you have to go through that translation table. And so it's a choke point, like all of the API calls have to go through there, which is what the dynamic invoke that Rostomouse and then published. I think Wover worked with him on that as well, which circumvents going through that translation table, like by just like making the direct kernel calls. And then we can also corrupt the detection processes. We can patch AMSI, we can patch ETW, and then we can do API on hooking. So like this is the event log. So it's made up of 3 primary components for event tracing for Windows. The controllers are what build and configure tracing sessions. Providers generate events for the consumers, and then the consumers interpret the generated events. There are tons and tons of different event providers. There's a whole bunch of articles out there. Actually, Anthony, if you don't mind, on our staff channel on the Discord, if you remember a few days ago, I dropped that ETW blog post that shows how to build like a start the event tracing for ETW and use Silk ETW and that kind of stuff. If you could drop the link for everyone, that would be good. But the primary things that they're looking for from a .NET hunting perspective is they're looking for assembly loading activity. Lots of code does assembly loading. but they can look for when it's called and like the context and that kind of stuff. They can look at assembly name and function names. They can look for just-in-time compiling events, like if you're using MS Build or CSC.exe. Those are probably abnormal to run on a like a finance company's network. They shouldn't be seeing that. And then ETW also has various alert levels. There can be keywords that can automatically elevate alert levels. Custom levels can also be set by providers. Like an example of this is in the PowerShell logs, because PowerShell logs are still going through ETW. Or like if you do like get field on like a on an object, get field by itself is automatically elevated to an alert and logged, even if like script block logging is not turned on. Like it's defined by Microsoft as like a mandatory logging event because of the they view it as suspicious. So now so looking at that, just to show you guys real quick, I think I have some logged events that we can look at. So I have event viewer. Oh, I need to switch the screen, sorry. So this just shows like some of the different things that are in here. It's kind of hard to just dig through the event logs of .NET stuff, the .NET runtime stuff by itself, just because it produces a ton of logs. But you can see like here, like it's showing like a class being built and the assembly being constructed and running in here. And so there's a whole bunch of information about all of the native functions that are being called. So it's like an interrupt call. That's why it's being logged, because I configured it to do that. It shows like the assembly names that are being loaded, which assemblies are being loaded. And so it's ETW has just tons and tons of information that is available to it. So this is where like the EDRs and stuff are getting much more advanced, and why like they are much more effective than just traditional AV that's only doing like standard behavioral analysis and that kind of stuff, because ETW lets you get like very low level into the events that are happening within the computer. It looks like I may have a question. Yeah, and we have a built-in ETW bypass into Empire that we added.
Yeah, and then I think we integrated Phantom as well, right? That was like one of the early things that we added in.
I think so. Okay, so now we're going to talk about sandbox stuff. So, because that was just the overview of what we're looking for in our dynamic detections. Now we're going to go into sandbox detection. So sandbox indicators are kind of an interesting problem. Our introduction to sandbox evasion and AMSI bypasses course that we taught at DEF CON a couple years ago now has like a lot of these slides came from there, but it has a longer section on how to do all this and building like VBA macros on identifying this. But so sandboxes are limited by, so there's two things, or a couple of different ways we can abuse sandboxes. We can detect them and do nothing about it. We can do something like try to outweight them, or we can just kind of do behavior that we think is normal for users, but not for a sandbox. So that's things like waiting for, if we're using VBA as the example, waiting for like a document to be closed instead of just opened, or for characters to be typed into the document, things like that that are more likely to be done by a human than by the sandbox. But sandboxes for emails, which is what this is geared towards, because that's where you most often see them still. You will see them. We're starting to see them more, like Defender's supposed to be releasing or Microsoft's supposed to be releasing a update to Defender that'll sandbox like out or Office documents and that kind of stuff. But they use a lot of resources, which can be expensive, and users don't want to wait to receive their messages for emails. And like they have to do it quickly, and so their sandboxes are limited by time, resources, and money. So we have several means to try and detect or evade them. If we're doing phishing, we can use password protection. We can do time delays to attempt to outweight the sandbox, because like I said, sandboxes use resources. So even when AVs are using sandboxes, they typically don't permanently sandbox the Office document or something like that. They'll temporarily sandbox it to analyze the behavior and then move on. That's particularly true for like EXEs and stuff rather than Office documents. And then, like I said, auto open versus auto close. We can look for limited resources, because since we're emulating like that we're on like a system or whatever, it typically doesn't have like a high number of cores or things like that. And then we can look for virtualization processes. So some of the evasion techniques, like I said, we can wait. So we can check and see if we think we're in a sandbox, and if we are, we do nothing or do something different that's less suspicious. We can password protect. We can, like I said, wait, doing time delays. Time delay, like sleeping in macros, or something to keep in mind for doing sleeps and stuff, is if you are embedding it into something the user is going to be interacting with and they attempt to close it, but it's got a wait in it, it'll hold the window open, so that can tip off users. And then this is where we get checking into resources. This is done through WIMI objects, which are available in C# and PowerShell and all the .NET stuff, but they're very inconsistently implemented. So like some manufacturers will implement them, others won't, or they'll have different things that they include as part of the WIMI object definition. So usually you want to use more than one of them. Some of the useful ones to check are computer system. So we could check like for a logical disk, we can check for a fan or a video controller. What's kind of interesting is for on the video controller one is you'll often see video controller defined for laptops. Like it'll tell you that there's a monitor connected on a laptop since it's permanently connected, and desktops won't. You almost never have the video controller defined. So it's just kind of an interesting thing to be able to tell if you're on like a laptop versus a desktop. And sometimes sandboxes will implement the video controller, but they usually don't. So most, if not all, sandboxes also result in the addition of management processes that we can look for, which will be shown in the Win32 process. Sandboxy has those SVIE service, SVIE control. There's VM tools for VMware. There's VBox service for VirtualBox. So we can look for those things, as well as, like I said, known AV processes we can look for, or things like that, to let us know that we have to deal with those on the box. There's no one way guaranteed to work, but you can look on the MITRE ATT&CK framework. They give a lot of examples. That's a place I like to go check, because they have some of the sandbox evasion stuff on there. That's where I got some of this stuff from. But you can just try a couple of different halting conditions. The more you know about the target environment, the better you're able to probably dictate whether or not you're on an actual computer or in a VM. So knowing as much about the environment as possible helps. So commonality between sandboxes can be used as a fingerprint. So this is something that we can do once we get on a network. Usually if networks are using sandboxes or an email server is using a sandbox, every time that sandbox is spun up, it has consistent like quote unquote physical attributes about it, like the number of cores or the RAM or the disk size. This was how we were actually able to evade Outlook sandboxes for a while. I haven't gone and checked if this is still working or not, but they always had two disks with the same size, and they also always had the same identifying number, like the SKU or the serial number, depending on which manufacturer you're talking about. The sandbox always had that same number, so that combined with the disk size, we could identify Outlook sandboxes. Oh, I thought I had the bypass slides in here. I can go open those real quick. So while I went through that quickly because I know people had some questions about the sandbox stuff or the bypass stuff. We had and so I wanted to get through that quickly. But were there any questions related to like the sandbox stuff? Well, I grabbed the slides for the bypasses. Coin, if you want, like, let me know if there's any questions.
Yeah, sorry, I'm just getting caught up in the chat. There's a lot going on, a lot of good resources that have been dropped in here. A lot of stuff from Secure This Shit, because we use a lot of his stuff, so. Let's see, Empire has an option to add sandbox detection. We still have the one for Outlook, right? Still built in?
Yeah, we do.
Okay. Can't guarantee it works very well, but I'm pretty sure it still works. I don't think they updated any of the sandbox evasion, like on the size of the disk. So I think it still works. It's just you don't get the callback out anymore like it used to have.
Yeah, it used to. So the sandboxes used to allow when they're doing the behavioral analysis, they'd actually allow the payload to call out to the internet. That was how we were able to collect the information regarding the status of the sandboxes, was they didn't isolate them.
Yeah, that was bad. Let's see.
Okay.
Somebody asked for does anybody have any insight for flagging deinvoke? Like it certainly is like the next big things for years to come. It says admins will not bother to get shady enough to use it. So will they flag it equals an easy win? So I know you have some experience with deinvoke, so.
I have a little bit, but like defending is not my. I have not done a investigation into the indicators on deinvoke and how consistent they are. Yeah, that's probably a good thing to go research, but I have too many things to research and not enough time.
I'll write it down for you.
Yeah.
And then
After my VBA stuff and my Empire updates and
yeah, we got a lot going on. Yeah, C# agents coming soon.
yeah.
How do you advise clients on remediation? And then the quote was, yeah, we obfuscated a bunch of custom code to bypass Defender. So like, what's the advice we give clients when we break their stuff?
So usually what it comes down to is a lot of them have technology or devices that are capable of identifying even our custom obfuscated code. And flagging it, they just don't, a lot of them buy it without implementing it properly. So like we've seen smaller companies that don't want to pay for like a SOC or whatever, so they go pay, it's cheaper for them to pay like 40 grand a year to Darktrace, and they buy Darktrace, but then they don't actually set it up. So like they had like those products are capable of the detections. So normally the remediation is helping them understand like the types of stuff they need to configure and go look for. So that's usually where our remediation focuses around is that we try to help them understand that just because they went and bought something off the shelf doesn't mean that it's fully set up for them and that they need to configure and that kind of stuff.
Yeah, it happens way more than it should, and they spend lots of money on these products.
So that's where remediation focuses around. And then we will also purposely we'll see how far we can get with that code or with like our obfuscated code, and then we'll also at points use like unobfuscated code to see if it's detected and that kind of stuff, and we try to give them, rather than saying like you're good, bad, we owned your network or whatever, we try to give them a like risk picture saying like, okay, you were detecting these unobfuscated things, which will protect you against these types of threats, but like our custom code was able to get past. And so like we try to give them a spectrum of the idea of what they're looking at, and not just a like we came in and destroyed your stuff. So we'll jump into the AMSI bypasses real quick. Rotation mode on. What screen am I sharing right now? So you guys should see the AMSI bypasses now. So I kind of already spoke to it, but basically the obfuscating is time intensive and creates a lot of additional size in our payloads, which can be flags in and of themselves, either based on network traffic size, the amount of memory we're utilizing on the endpoint, that kind of stuff. So we don't really want to have to obfuscate everything all the time. As I mentioned, here's that kind of numerical evaluation I was talking about for AMSI results. I've never actually seen a 0 come back for a clean.
Hubble, for
Because
some reason I'm not seeing your slides real quick.
what am I sharing right now?
I see it says AMSI bypasses, but nothing, no.
Oh,
there we go.
There we go. Sorry about that. So I've never actually seen a 0 come back, because if you go look at the source code, when it says a 0 comes back, that it apparently means that like it could never be used for malicious purposes, but everything, and especially when you're talking PowerShell or .NET where reflection is an option, with reflection everything can be eventually changed to be malicious. So I'm not sure why the 0 exists, but typically you'll see either a not detected, or which is a 1, or that 32,768 come back. It rounds, so like I said, you never get an actual numerical score from your results back. It rounds it to these to one of these 5 numbers. So it would be awesome if we could get the actual numerical score, because then you'd know how close you are to getting past, and it would make obfuscating much easier, but we don't get that. So this probably isn't a valid obfuscation anymore. But when we initially built these slides, because I went and grabbed some of our older slides because I thought had the updated ones in there. When we initially did this, like this is just a netcat reverse shell to like a netcat catcher. This got caught. If you just changed it from the PowerShell wave defining new object to using the assembly to call it directly, it would go past Defender, but like you'd go out and look at guides and you'd find like these super complicated obfuscations, which is why like I like to emphasize learning how to do this by hand first and then using automated tools so that you understand what you're trying to do, because often if we don't have a good clear understanding of what is actually triggering our detections and why they're triggering, it makes the obfuscation a lot more complicated than it needs to be. So the first bypass is the reflective bypass, which is the which is the one that was published by Matt Graber in a tweet all the way back in 2016 and is fixed because despite how important AMSI has become to detection methods of that kind of stuff, it's not like officially considered a boundary, a security boundary, because it's hosted in our process. So there is no intention to go fix this. So it'll continue to be useful. One thing to note about this, though, especially if you're using mixed payloads where you're using PowerShell and C# or other .NET languages, is this will only disable AMSI within the PowerShell runtime. It is not patching that lower level like API layer of the AMSI initialization. So like CLR detections will still happen if you use this reflective bypass and not one of the memory patching ones. So it patches the AMSI scan result. We're setting the AMSI init field true, which forces which the source code shows causes an AMSI to return a result not found. Basically, we said that the initialization failed, so that and they made the design decision that if AMSI was corrupted during load, that it would just return a results not detected rather than blocking everything, because that could break things. So that's if we say that if we corrupted AMSI while loading, then the scan is automatically returned as no results. And as I said, it's hosted in our process, so that's why we have access to do whatever we want to it. So this is an AMSI bypass that I wrote, which is based off of Tal Lieberman's one that he posted at Black Hat. It's fairly similar to the one that Rostomouse has also published. But it's a little different. Mine's a little shorter. His is a little more robust in terms of like the proper coding stuff. But this removed about 20 or so lines from the code, so I like the code to be a little more compact. But this is where we're actually patching the memory. So that in the previous one, the scan never happens. And this one, the scan does happen, but the result is forced to always be returned to no results detected. So we use C# to export a few functions from through pinvoke. Then we add it and we patch the memory process. Something that is actually pretty interesting that I can show you guys real quick about this is you actually don't have to marshal the memory. Just using that just changing the virtual protection on or the protect flag on the AMSI process or like memory space seems to break it for some reason. It's like a kind of nice obfuscation trick that I found the other day, because that it removes a few more additional lines of code that we could have been using. So let me grab that code real quick just to show you guys. Getting in the way. So if we do our AMSI context, see that it's flagged as malicious. This is still the one-liner, but as you can see here, if I go back, pull up the PowerShell window again, I don't have this last line where we're actually marshaling and copying the code into the buffer, or these like buffer new object or these any of this code right here where it says like buffer 0 for the flags to copy in. I don't have any of that in there. It's just changing that virtual protect flag, and then when you hit enter, it now disables it. I'm not sure why that happens, but it was a thing I found out when I was trying to obfuscate code like a month or so ago, trying to figure out exactly what in the bypass was getting flagged, and so I removed that bottom section, and then it still worked. So just kind of interesting tidbit there. So, and then this is the final bypass I had. As I mentioned, ETW is a very effective way of hunting .NET, but we can reflectively modify the PowerShell process to prevent events being published. So we can use the system.automation. This is because it's specifically defined for a PowerShell ETW log provider that we can disable. And then that disables like a lot of the that disables the PowerShell ETW. It does not disable CLR though. So if you go to load in an assembly, there's still the CLR provider that you have to actually go patch memory, and is a more complicated bypass than what you use just for PowerShell.
If you're looking through questions, I know Itachi mentioned, why doesn't Microsoft fix this? I know you kind of covered it, but if you want to hit on that again.
To be honest, like they could move the context. I think it's because the interface, so they could move they could host some of it differently. It's because the interface has to be attached to the process that you're pulling code from. So there has to be some interface to the AMSI process, even if you're going to a lower level. The process you're in has to have that pipeline to pass the information out. So we can abuse that pipeline to send the information to the lower level. And actually, exploit coder might have a better answer too. I know he knows a decent amount about this. Yeah, but the Graeber's bypass requires very little obfuscation to run. It still mostly works. You just got to make sure the word AMSI isn't in one piece in it, basically. Oh, I didn't know if you had any insight into the why Microsoft hasn't moved AMSI out of like your hosting your process. So it's largely because of the interface required to pass the information out of the process. And so we can abuse that pipeline out when they're passing the information from the compiler. I didn't know if you had any other. Oh. So yeah, we're about 10 minutes early on the webinar, but those were all the things I had. If anyone has specific questions, I'm happy to answer them, or I could show off we didn't go through the, I skipped the Empire payload obfuscation and PowerShell because we weren't gonna have time for it, but. Okay, yep. So. Where is the control for this?
Well, while you're getting that pulled up, so I know since we're coming up on time, and some people might drop off while we're doing some of this stuff, we are offering a course next month if anybody's interested. That's going to teach you all about threat emulation. There's a whole section on initial compromise and obfuscating payloads and all that stuff. So if you're interested, I think VinnyBot's going to drop a link in there. Check it out. It is. I have a few seats still available, so sign up if you have a chance.
Yeah, and we have I know one of the sections that people really enjoy in there is we have some pretty cool red team infrastructure. Yes, if Itachi, if you sign up for the course, we will provide video recording from each day that you can hang on to, and we share the slides and stuff with everyone.
Yeah, we do that, and then we also have we provide 2 weeks access to TryHackMe, which hosts our infrastructure for the course, so it has the full network in there. So that way you can go walk through all the steps in there and have cloud access to that as well. So pretty awesome. We worked with them to kind of set all that up, so those guys have been great.
Yeah, but okay, so we'll look at the base Empire stager. So basically, there's a whole bunch of stuff in here that we can start playing with. This is the base Empire payload with that's which one? The base Empire payload with script block logging. The Matt Graber's bypass is the one that's currently in here, and then we have our actual download cradle. So like I said, Microsoft or Math is getting really hard to obfuscate out because AV is starting to zone in on it. So the actual hardest part of obfuscating, so we can get just the download cradle passed with some work, but we can go look at it. And actually, sorry, I need to turn the real-time protection back on first. So with our default payload, it'll turn on and it gets flagged as malicious. So there's a couple of pieces in here that just because I've been obfuscating Empire for a very long time at this point, I know that are going to be a part of our initial flags. So like just taking out like the RC4 encoding is usually enough to get us started on our. Didn't like that. Why didn't I cut that out? Oh. And if someone has a good way to re-implement RC4 encoding, we'd very much appreciate it if you shared it with us. So as you can see here, let me zoom in to make this easier. So now we just removing that RC4 encoding, the whole payload runs. It didn't work because we can't decode the payload that came back, but it's like we know that's suspicious. What are the other sections in here that are typically suspicious? The placement of the headers and stuff is usually another thing that is suspicious. And then as well as this join statement down, using this join character thing, we actually don't have to use join. We can use some of the assemblies that do that like convert byte arrays to strings. Like, so over in this working one, I'll grab this one and we can go through how I've obfuscated this part of it. So this other thing is we have this like thing in the default Empire payload, there's also this system service point exception container, which basically tells it to ignore, like regardless of exceptions, don't close. That can also be used as part of your flag sometimes. But let's clear this. So if I go through, why did it? That was weird. So here's so this is a payload that I know will get passed because I obfuscated it. Some of the primary things I did, well, here, some of the primary things I did was I changed the name for the obfuscation from R to just a random word. I moved it in its order of where it is because this Excel or RC4 encoding is independent. We just need to have it done before we try to decode the data we downloaded, so we can put it anywhere in our code prior to this line. So I just moved it to the top because moving things around helps. This news.php, I didn't need to obfuscate it, but it's actually a known flag as well, because it's one of the default pages for Empire. So we could change that in Empire to a different name, and that would help. Or we can concatenating also helps it here. But I actually have obfuscated this one enough that I don't need to do that. And then I also changed how we're doing this IEX part, or the decode part. So I'm using a so down here you can see we're using this join on a character array. Instead, we can actually execute this inside part to get a byte array and then get the string from a byte array. And that changes how we're doing things enough that it'll actually allow it to execute. So now we have a working payload going back. So I don't know if anyone had any specific questions, but we're kind of at the end of our time now. I'm happy to go over more specifics on this PowerShell obfuscation. Which Blackmagic snippet, where I re-implemented the join? Or the random C# code that happened to help me obfuscate my stuff? Oh, I know. I'm aware, exploit coder. It's part of the job. So this is how I re-implemented the join down at the bottom. So I haven't looked at NIM too much. I'm a really big fan of the DLR stuff that Marcelo Bytebleeder has done with Silent Trinity, which is like that Iron Python type of stuff. I tried really hard to actually get some of the DLR style stuff working in Empire, but it turns out that the Empire engine, or sorry, not the Empire engine, the PowerShell engine is like this weird hybrid beast between CLR and DLR and all that stuff, and the things in it don't like quite work properly for you to be able to host the PowerShell compiler elsewhere, because there's some contextual stuff that's taken from the machine for compiling. So I tried really hard to be able to try and like compile the intermediary language on like a remote box and then send it over, but it did. I spent a lot of time trying that, but I think the DLR stuff is really cool. Which is not quite on a remote box compiling it and sending it over, but just the DLR stuff in general is really cool.
And I'm going to touch the Iron Python one. Somebody tried to implement Iron Python in the old Empire project. I think it was like 2 years ago. Someone tried to implement it. The direction we're going with Empire should make implementing those things a lot easier in the future. So we might be able to port some of that code over. But that's a lot of the work that we've been doing recently, is trying to make Empire, like as the server, a lot more streamlined and easier to use. That's especially what Vincent's been pushing, because he's actually a programmer and me and Hubble are not. An Empire training course. Oh, Vince, can you drop a link to the CLI thing we just did? The new CLI thing we did actually was a pretty good Empire training course. We teach a little bit. We do like about an hour segment in our course on Empire, but like we try to not teach Empire specific because we want people to kind of use whatever C2 framework they want. But I haven't really thought about, I don't know if you thought about it, Hubble, of just doing something completely dedicated to that.
Well, we usually do one at DEF CON. Like we were, like
Oh,
we
that's
were,
true.
yeah,
Yep.
like we were We had a workshop at DEF CON last year before they canceled it. Like, so they normally accept us to, and we come and teach like Empire specific stuff there is usually where we do that.
Yeah, if we're lucky and DEF CON have to do workshops again next year, keep an eye out, and then hopefully we'll be able to teach probably, it's about typically 4 hours long. So you'll have a 4 hour opportunity to join a 4 hour course there. And the
And
nice part
then,
is they're free, well, somewhat free. I think they charge $25 is what they charge people.
yeah. And then, also our introduction to, oh, did we cut for the, can't remember when we did the webinar last year, did we cut out the Empire part of it? Because we did teach Empire when we taught it at DEF CON
I
for the
think
introduction
I
to
think it
AMP.
has a little bit of it, but most of it was cut
Yeah.
out.
Oh yeah, that's how we got it down to like the 2 hour time space instead of the um the the 4 hours that it was originally. Actually, secure this shit. I actually, as part of the C# agents that I've been working on for Empire, I have an entire new C# stager that's like running the C#. The process is actually a C# process and not just a PowerShell process that can execute PowerShell.
I won't have to keep stealing your already done modules and implementing to Empire, even though they're great to use. So thanks.
So, Arky, like full disclosure about what I'm working on for the C# agents is I basically ripped out the Covenant Roslyn compiler, and so it'll be compatible with all the Covenant tasks that are already existing out there. We're trying to make everything as interoperable as possible so that when you have like Covenant tasks that have been built, you can take them to a Covenant C2 if that's what you want to do using those YAML files. That's why we're using the same malleable C2 profiles that Cobalt Strike uses. Like our goal is to make empires interoperable as possible. Yeah, I would love that. Would be a whole other thing. I'd love to get the attacker scripts working with Empire, but that would be a whole project in and of itself.
Yeah, that'd be crazy. I would love to do that. I mean, the malleable C2 stuff was hard enough as it is. Luckily, somebody else did 90% of the work. I just had to get it working. But the attacker scripts would be nice. I know the new CLI has at least the scripting's a little better for the auto run stuff. That's something to look at if you haven't already looked at the new Empire CLI. Is the YAML file stuff is a lot more robust than kind of how things were before. Yeah. I think Vince will drop you a link in just a second.
Yeah. So I'm gonna go ahead and end the webinar at this point, but we will be around in the Discord server, so feel free to keep asking questions there and we'll respond.
All right, awesome.